iScience 10. So in this video, we're going to be looking at atoms and elements, which are on your periodic table. So that's what your periodic table is. It's a list of all of the atoms and elements. And of course, compounds. And compounds are when two or more different atoms bond together to form something new. You know, for example, and we'll talk about it a few times, sodium chloride. So this is the metal sodium and the gas chlorine to make a brand new compound with totally new properties called sodium chloride. So yeah, we're going to be looking at atoms, elements, compounds, and of course bonds. And when atoms come together, sometimes they form a bond, and that'll happen obviously in a compound, but sometimes even oxygen, O2. Oxygen likes to bond with other oxygen atoms. So oxygen exists as O2. Hydrogen, for example, exists as H2, so it's two hydrogen atoms bonded together. So we'll be looking at that. Now, to understand chemistry, matter, the study of atoms, the study of elements, you need to kind of think about what you already know. And really, most of what you know are actually mixtures. So, you know, for example, a rock is going to be made up of compounds. Probably most of them are going to be ionic, in other words, a metal bonded to a nonmetal. So for example, this rock probably has some aluminum because it's a little bit gray, but it's aluminum oxide. So it's aluminum bonded to oxygen. See, it's very rare to find pure, you know, any of these elements in their pure form. This, of course, takes a lot of energy. This is aluminum. It takes a lot of energy to make this. And it is actually pretty rare to find elements in their pure form. They're usually bonded in a compound, and then their properties are totally different. Or you could get mixtures of pure elements like the air that we're breathing right now. Now, of course, you can't see it, but you know we're breathing in oxygen or O2 gas. But in fact, mostly it's nitrogen gas. It's a mixture of oxygen and nitrogen gas. There's obviously a little bit of carbon dioxide and other gases. And again, those gases are all in their pure form, but they're all mixed together. So it's a mixture. You're not going to get a pure amount of oxygen unless you've got a cylinder, unless, you know, a human industry makes it in its pure form. So yeah, this periodic table, and again, make sure you've got it printed in front of you, shows you all of the atoms, all of the elements. Again, that they don't probably really exist that way in nature. Sodium, for example, is highly reactive, as is everything in this group. This is called group 1. All of these, especially these metals here, they're very reactive. Here's sodium. If you put sodium in water, that's when it looks like it literally starts water on fire. So it's highly reactive. And of course, water is a compound, right? H2O, so a couple hydrogens bonded to an oxygen. And in the reading, I know we've kind of talked about how carbon and hydrogen bond together. So we're talking a little bit about how things bond together. All right. So yeah, so down here as well, sorry, we've got a model of what happens. Sodium loves to react. I mean, again, you're not going to find it in its pure form. We've got a model of what happens when sodium gets together with chlorine. Now, chlorine is a dangerous gas. Again, super reactive. You're not going to find it in its pure form unless you go to industry somewhere. But when sodium and chlorine get together, they make salt. So you get a compound with a totally different properties than the sodium metal, and it does look much like aluminum. But of course, if I had sodium in my hand, literally my fingers would be burning off, so I couldn't have sodium in my hand. And chlorine gas is a green colored gas. It looks very scary, and it is incredibly dangerous. You put those two super dangerous things together, a lot of energy is released, but then you get salt, and it's quite stable. And salt has totally new properties. So that whole idea that each of these atoms and elements have their own properties is, of course, important to understand. But also, when they bond together with each other, they'll form a new compound, and that compound will have its own properties. So those are some of the basics of what we're talking about here today, and some of the basics. You know, when you're looking at a periodic table, make sure you appreciate what you're looking at. It's the different atoms, and you're not really going to find them in nature, and they're usually going to be bonded. So let's start looking at that. I'm going to share my screen so we know where we should be at in the course right now. You've just finished the welcome video, but yeah, let's share the screen. All right, here we are. Make sure for sure that you printed the periodic table. You absolutely have to have it every day, and you'll be using it. You'll be using it in this lesson, so I have it right beside you right now. Here's our unit plan, so that you've watched the welcome video and done the welcome assignment. We're still working on day one, this video that we've got here, and once you complete that and one more little video and some reading, you'll be able to do the next assignment, atoms, elements, and bonds, and then also the protons, electrons, and neutrons and isotope assignment. So we're of course working in chapter 1 in the textbook. It is optional, but we've got that in the Moodle course, so you don't have to have a physical copy of it. These are our main notes that you need to be reading every day. Following along, this shows you the pages that you need to be reading, and this plan isn't fully updated yet, so you'll have the most up-to-date version to tell you all the pages to read. And this is, again, you've already read this part here. In these lesson notes, there's of course questions that you need to be answering. But yeah, let's start with today's video. We're going to be looking at atoms, elements, compounds, and bonds. We need to know the structure of the atom. We've got one right here. We're looking at a carbon atom. So you might, and in fact you do, you want to pause the video right now, and what I suggest you actually do is draw that carbon atom out as you see it here. So you just hit pause. Okay, you're probably back with your carbon atom drawn. You want to know that the valence means outside. So write that down, write this down as well, but also write down that the word valence means the outside electrons. So in their model of carbon, you notice that you made 4 outside or valence electrons. Those are the ones involved in making bonds. It makes sense if you're going to put either 2 carbon atoms together, and carbon loves to bond to carbon, or carbon bonded to hydrogen, and in the notes you've read about how that works. Carbon can actually bond to a lot of things. Ultimately, it is those valence, those outside electrons that cause the bonds. I mean, chemistry maybe should be called electron study or valence electron study. And we're going to go over some of the basics of the periodic table. You do need to be getting very comfortable with it already, but definitely after this lesson you should know some key information about the periodic table. But let's start with the structure of the atom. Well, atoms are made up of protons, electrons, and neutrons. Specifically, the protons and neutrons are found in the center of the atom. Now, an atom they're super small, but there's even smaller things that make up atoms. You can't just those split atoms in half, well, unless you have a nuclear bomb, basically. So let's, again, make sure you're pausing the video and writing down this key information that's here. I'm going to write down some as well that you're going to want to write down about protons, electrons, and neutrons. We're going to talk about the carbon atom here. So you got protons in the atom, neutrons, they are together in the center of the atom. That actually makes up the mass of the atom. So this gives the atom its mass. This gives you your mass because you're made up of atoms. So it's your protons and neutrons that are inside of your atoms. And electrons. Now, some interesting things about protons, they have a positive charge. And electrons are the opposite. They have a negative charge. Those two balance out. Atoms are electrically neutral. Atoms have no charge. The charges are balanced. That's important, and we'll be talking about that a fair bit throughout the course. So atoms are electrically neutral. By saying that, what we're saying is your protons equal your neutrons. Now take a look on your periodic table. I've also got a copy of this section of it. Find carbon. You'll see carbon is 6. That's the proton number. The atomic number is the proton. Tells you how many protons. Okay, so carbon's got 6 protons. We'll skip neutrons for a moment because I just mentioned how atoms are electrically neutral. So therefore your protons have to equal your neutrons. If we're talking about a carbon atom, which we are indeed talking about a carbon atom, 6 protons, 6 electrons. Now to get the neutrons, it's a really cool little task that we do. We find the mass, which is right on our periodic table. So this is a mass of an exact amount of carbon. In fact, about 6 trillion carbon atoms, so a whole lot of them. And they have a specific mass of 12 grams. And we take that mass number, which is 12, you round it to the nearest whole, because you'll notice these are not always round numbers. So we're going to take the mass and we're going to subtract it from the number of protons. And of course that's 6. Well, 12 minus 6 is 6. There we go. That's how many neutrons. There you go. That's the carbon atom. This information, you can now use the periodic table and you can figure out how many protons are with that each of the atoms have. You can figure out the number of neutrons just with some simple math. Again, round to your nearest whole number. So boron would be 11. And then electrons, well, that's dead easy. If you got the proton number of 5, well, then the electron number is 6. Here's some other models of atoms. Again, you want to be probably pausing and getting this information down as I'm lecturing you here on the structure of the atom. But let's take a look at just a few other atom models here. What we've got basically showing us again is that in the center you've got your protons. They're positively charged. Also in the center of the nucleus, you've got your neutrons. They actually have no charge. That gives the mass. So all of the mass is there. Circling in little orbits or energy shells outside is the electrons. And the key thing that we want to know for chemistry is valence electrons, or the outside, those valence electrons. They're the ones that make bonds. They're the ones that really do chemistry. Because I mean, without chemical reactions, without explosions, without new substances with new properties, chemistry, well, is nothing. It would be quite boring. So yeah, so maybe take a look on your periodic table and which one does have 8 protons, which one has 7 protons, which one has 17 protons, which atom models are these? I'll let you try to do those on your own. Yeah, let's take a little look here though. I'll show you, but yeah, you check on your own and then let's look together next. All right, well, again, using your periodic table, 8 protons, is that oxygen, is that nitrogen, is that chlorine? Well, pretty sure that's the oxygen atom. Indeed, oxygen's got 8. You can see the 8 plus 8, there's our 16, there's our mass. And of course, 8 protons got 8 electrons. I wonder which one of these is nitrogen. So nitrogen, it's got a 7, so therefore 7 protons. Oh, there it is. Again, check out the mass of nitrogen. That rounds to 14, so therefore 7 protons, 7 neutrons. If it's got 7 protons, it's also got 7 electrons. Again, you might want to pause the video and just kind of figure this out as I show you. And yeah, that one's obviously the chlorine atom. Check out the mass of the chlorine atom. Remind yourself that this mass is the protons, so the P, or the protons, so I'll just write it out, plus your neutrons. So we know protons is 17. Plus, oh yeah, that'd be 18. That'd be 18, yeah. And you get your 35 as your mass. All right, so we've had a chance to look at the basics here, the basics of the periodic table. Next, we're going to look at how chemical bonds happen. And a reminder that those chemical bonds happen with the valence electrons, the outside. They make chemistry happen. Valence or outside electrons sort of makes sense, right? Like if you're going to be putting atoms together, that it is going to be the valence that's going to interact. So, if we've got oxygen coming up here, to carbon, that it's going to be its valence, it's going to be its outside electrons that are going to be interacting, that are going to be forming the bonds. So yeah, let's take a look at that. All right, let's take a few notes here. First of all, and again, make sure to have your periodic table in front of you. Chemical bonds. And all right, so those could be for a compound, right? So you could have two or more different atoms, or it could be, you know, an element itself, so in a pure form, and so it's the two or more of the same. You know, so two or more different atoms. An example would classically be water, right? Good old H2O. Oxygen for the element one, O2 gas. You're breathing that in. You're also breathing this one in, but you don't use it at all. Nitrogen gas. In fact, 78% of the air we're breathing in is nitrogen gas. We don't even get to use it. Plants and certain bacteria, more bacteria than plants, bacteria that are in the soil can grab that nitrogen and get it into plants, and then from plants we get to eat that nitrogen, and it helps make our DNA and our proteins. Main point being that these bonds, whether it's H2O or whether it's O2 gas, these chemical bonds are happening. It's because of the valence electrons. We're going to look at an example where sodium, right here, combines with chlorine gas. And of course it makes good old salt, right? And it is all about these outside valence electrons interacting and bonding together, form a totally new substance. Kind of interesting that chlorine gas, like oxygen, is an element that forms a little tiny molecule, two chlorine atoms bonded together. We can see them here bonding together right there at their valence electron, kind of tying them together right here. All right, so yeah, so really, how do we do this? How do we know what happens when sodium and chlorine get together? The answer's on the periodic table. You want to make it your habit, and it will be your habit shortly in this course. If you need an answer, look on a periodic table, because that's how it's designed. It's designed to give you answers. So first of all, what you need to know is that on this side of this staircase, these are all metals. You know, kind of like the aluminum that I've got here. Shiny, malleable, ductile, they can conduct electricity. Then on this side of the periodic table, they're nonmetals. They're actually opposite almost. Whereas metals are shiny, nonmetals are dull. Whereas metals, they're all solid except one, right? Mercury is actually a liquid, and you can see that from the periodic table. Whereas nonmetals over here, some of them are gas. Again, you can tell that these are gases. Some of them are solid, a fair number of them. And one of them, bromine, is actually a liquid. So they're all over the map in terms of their state. But here's what metals do to make chemistry happen, is they can give their valence electron. They literally give it away. Whereas nonmetals take electrons and add them to their valence. That's interesting. Again, you're going to want these notes in your notebook, but also you're going to make little tiny notes later on your periodic table so that it's got the key information summarized, because you need to just know this like you're breathing. Now the charge, you'll notice, look at the charge on all the metals. You'll notice a pattern. In the periodic table, it means table of patterns. You'll notice the charge on all the metals. You'll notice a pattern. They're all positive. And it tells you how many electrons each atom gives away. So the charge shows how many electrons from its valence For example, sodium 1 plus or plus 1 gives away 1 electron. Iron, the most common form of iron, gives away 3. There are some forms of iron that give away 2 electrons. So some of these are multivalent. They have 2 different styles of basically iron. It looks exactly like iron, but some of them only give away 2 electrons. For example, aluminum, 3 plus, so it gives away 3 electrons. Check out the charge here is negative. This means it accepts electrons. Chlorine will take 1 electron. Oxygen wants to take 2 electrons. So let's write that down, that this charge shows how many electrons it takes. So we're going to see the reaction between sodium and chlorine, because sodium, if you find it, make sure you can find it right there, number 11. Sodium is definitely a metal. So it's shiny, malleable, ductile, because it's in what we call group 1 on our periodic table. And we'll talk more about this as the course goes on. But all of these here, this is group 1 down here. All of group 1 are highly, highly reactive. And they all have a pattern too. Look, give away 1 electron. So we're going to look at the reaction between sodium, a metal, and chlorine over here, a non-metal. Group 17, where chlorine is, and that's fluorine, chlorine, bromine, iodine, astatane. All of these are also violently reactive. So we're going to see what happens when sodium and chlorine get together. We've also got a video linked in the notes that you're definitely going to want to watch. If you haven't watched, you do want to watch that as well in our notes. But yeah, let's see this reaction. I'm going to pull up my next slide. All right, so we're going to take sodium. So there's a model of the sodium atom. Notice the single electron. It likes to give it away. And there's actually almost like a little space here, right here, where chlorine can take it. Right now, these 2 chlorine are bonded together, so they're kind of held together right there. But that bond can break, and sodium can take it over, actually. But yeah, let's talk a little bit about this. So we're going to take sodium and combine it with chlorine. Let's scroll down here. You've got a picture. This is what sodium looks like. And we're going to combine it with chlorine, and you know what salt looks like, and you know salt is safe and tasty and wonderful. Sodium is deadly, 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 and chlorine is deadly, deadly, deadly. We're going to take 2 super deadly things and make sodium chloride, or what we call table salt. Nice and safe, tasty. All right. Well, a reminder right here. We've got our staircase, right? So on the one side, we got our metals. On our other side, we got the non-metals. So we know that sodium it's going to be willing to give away 1 valence electron, and chlorine is going to take that 1. This means a chemical reaction will happen. This for sure will happen. This is the power of the periodic table. Just by looking at it, you know whether this reaction will happen. Because this is group 1 and this is group 17, you also know this is a highly violent reaction that you probably don't want to do unless you're in a very, very safe place. All right, so let's write this down first, just in words. So write this down with me. Sodium combines, and just make sure to write it on a nice straight line, with chlorine to form sodium chloride. We're doing chemistry, by the way. Again, make sure to write that down. So that's your word equation. Now sodium, all metals are just simply monatomic. The heck does that mean? Well, just a single atom. Now they still are glued together, not glued together, they're still bonded together, but it's not Na2, you know, how oxygen is O2. It does exist as two oxygen atoms bonded together. Sodium will just exist as single atoms, you know, especially if it starts reacting. So we're going to combine that with chlorine, Cl2. This is diatomic. It does have to have another chlorine atom. It helps balance it out, and it helps balance out those valence electrons. They actually are sharing their electrons, these two chlorine atoms. And yeah, we'll get that formula for sodium chloride in a moment, but first just you got your words, you got your formula here. Always have your state of matter. Your periodic table, if you're looking at it right now, it shows you the state of matter. Sodium is a solid. It shows you that chlorine is a gas. So you have that information right off your periodic table. Everybody in group 17 is diatomic. So fluorine is F2, chlorine is Cl2, etc. We'll talk about that again, but that's a powerful piece of information. Now again, from our periodic table here, let's just do a little bit of rough work. So you can just literally call it this right underneath. Write the charge for sodium. Take a look carefully. +1, right? Write the charge for chlorine, -1. Again, this is some rough work. You want to keep this looking nice and neat. So have this somewhere on the side. We can put it underneath for now, but you don't want to clutter this up with any charges. This should look nice and neat. This is telling us that this sodium has 1 electron to give and chlorine has 1 to take. So they're going to combine in a nice 1-to-1 ratio when we form sodium chloride. You just need 1 sodium and 1 chlorine, and these are always solid. These ionic compounds, these metal, when any metal combines with a non-metal, we always will get a reaction. You know, some of these maybe need a bit more catalyst to really get going, but these reactions will all happen. You know, aluminum and oxygen, you betcha. Lithium and nitrogen, you betcha. Lithium and phosphorus, you betcha, because we got metals on the left, non-metals on the right. When metal and non-metal combine, they always form an ionic compound. Interesting. Make sure to write that down. Let's draw this down here. So it is a sodium atom, and it's given 1 electron, and kind of right here, there was that space where chlorine grabbed onto it. I'll just scroll up. Just scroll up here. You see that? See how the chlorine, to stabilize, quote unquote stabilize, just a little bit more stable, it's got to have another chlorine atom together. So we say that it is, and it is indeed Cl2. But this little space here, it's ultimately saying, hey, I need an electron. Well, sodium can provide that electron, and the chlorine takes it entirely. This also explains its properties of this ionic compound, explains why it's a solid, so it becomes very stable. So ionic compounds become very stable. They form what's called an ionic bond. I'm just going to get a little bit more paper here, so I'm just zooming out, and I'll just zoom back in. There we go, and scroll down. Sorry about that. All right, so what we've seen is we've got this sodium atom giving its electron, and chlorine literally takes it, and they form a bond. So let's just draw a little bit of a, you know, we usually use a line to show a bond. So right there. And again, it's an ionic compound, so it's an ionic bond. And that is what we call when a metal and a non-metal come together and form a new compound, we call it an ionic compound. Now, the sodium and chlorine, and what we'll just do really, really quick here, we're going to put some salt in some water. So I'm just going to do this. and you can see me here. You can see my water, and I've got some salt here. You know what happens when salt goes into water. It's going to dissolve, right? You know that. And so we put it in. We can see that solid going in there. Might have to stir it for a while, but it will actually start to dissolve. And definitely if we let it sit for a while, it will dissolve. And ultimately, what's happening now is there's sodium ions. Oh, so not the sodium atom, because if there were sodium atoms in here, there'd be an explosion, a fire, and not the chlorine atom, because that's a gas. So these are ions, and an ion is an atom that's either lost or gained an electron. Now just kind of repeat that. An ion is an atom, but it's either lost, like the metals, they lose their electrons, or it's gained an electron. The non-metals gain them, and it does change them. It actually stabilizes them, because we know this isn't dangerous. I mean, it probably wouldn't taste very good, salty water, but it's not dangerous. We put sodium, normally sodium atoms. Well, this is what would happen with sodium atom in water. There'd be a fire here. So it's interesting, right? That single electron has changed the sodium. Very interesting, right? Okay, let's go back, share the screen, because we want to get some of this information down. But you've just seen an ionic compound dissolve. And let's write down what an ion is. So an ion is an atom. Again, write this down, but also know this. That has lost or gained electrons, or it could just be an electron, like with sodium and chlorine here. And again, just a reminder on your periodic table, your metals, they can turn into ions if those metal atoms give their electrons. And the non-metals, all of the ones with the charges, so take a look on your periodic table, all of the ones with the charges can form ions. Oh, that's so interesting, right? And that's what an ion is. And it, almost magically, of course it's not magic, it's science, but it almost magically stabilized that sodium. That sodium was so super, super dangerous. All right, so let's do a bit of a summary of what we've learned here today about atoms, elements, compounds, and bonds. So what we've been looking at is metals, on your periodic table, they've all basically got the same kind of properties. They're shiny, malleable, conduct electricity, and they all like to give away electrons. So these are your metals. On the other side of your periodic table, you have your non-metals. Now, chlorine is just one example. The interesting thing about chlorine is that it's a gas. Some non-metals are solid. Some non-metals are liquids. Well, bromine is the one example. Now, when these two combine, we get an ionic compound. Okay, and those ionic compounds, indeed, we can dissolve that and get the ions in the water. And the way we would write that in the solution here, we'd be NaAQ, the sodium ion. That literally is how I write sodium ion. So you're going to want to get this down. This is how to write a sodium ion right here. If you write down this, you're saying sodium ion. Here's how to write chloride. Oh, it has a little different name. Chloride ion, Cl negative 1AQ. Oh, okay. So this basically says, oh, I gave away an electron. It made me stable. I took an electron and it made me stable. Where'd you get your electron from, chlorine? Well, I got it from sodium. Sodium, who'd you give your electron to? Well, I gave it to chlorine. They don't normally talk. All right, so just some everyday common things. Well, table salt is made up of, well, it's a compound, right? It's made up of two different elements which have very different properties. These atoms here, the sodium atoms, they are electrically neutral. Now, you're not going to find them in nature, but atoms are electrically neutral. Remember, your protons balance off with your electrons. Those two balance off. And again, you're going to want to review this. And this is just, for some of you, it's the first time looking at this stuff. But this is important to write down and to know that, first of all, atoms are electrically neutral, and that ions are atoms that have either lost or gained electrons. And you know, oxygen is an example. You'll see its charge. Check out oxygen's charge. -2, right? Means it wants to take 2 electrons. All right, Science 10. Let's do a last summary here about ionic compounds, actually, because we've got a nice one here. Good old solid sodium chloride. Always write your state of matter and, you know, say the name, sodium chloride. Ionic compounds, 4 key things. First of all, it's a metal element, bonded, so it does form a bond. In other words, electrons are, in this case, transferred. They can also be shared, but in this case, the electrons are transferred. The valence electron gets transferred, bonded to a non-metal. Second thing about ionic compounds, they're always solid. Oh, that's interesting. Again, think of the power that you have with the periodic table. You can tell what things react. You can tell what kind of a compound they're going to create. Stable. Now, it doesn't necessarily mean that they're safe. Many ionic compounds, you would not want to eat them, for example. But they are chemically relatively stable. So you could still react many of them. Table salt or sodium chloride, you would need to do a lot to get this chemically reacting. You need a lot of electricity, a lot of heat, something fairly major to get an actual reaction happening with it. Another neat thing, and it's right here depicted with sodium chloride, is that most of them dissolve pretty easily in water. Now, when they dissolve in water, that forms a solution. Again, most things, you're not going to find pure water unless you go buy distilled water. Most of your water is a solution with things dissolved in it. Think of seawater. It's going to have sodium chloride, magnesium chloride, it's going to have potassium chloride, all kinds of things dissolved in ocean water. For those of you who live in rural Alberta, you probably are familiar with getting iron in your water, and it has that, you know, kind of very bad taste, really, actually. And that, you know, iron, it's going to be actually iron oxide dissolved in the water. So most dissolve in water, and of course form ions. They are going to form ions if they dissolve in water. Hey, they're ionic, and ions are charged. They do have a charge. And it makes sense that either you have gained a negative electron or you've lost one of your negative electrons. So, you know, for sodium, it loses one negative electron. Well, then it's got an overall charge of +1, because those, remember those protons that it has in the atom model? Well, there's now not a balance, right? If it's lost an electron, there's not a balance between its protons and electrons. So it's got a bit of a positive charge. Versus chlorine, the chlorine or chloride ion, again, we put aqueous because it's in solution, it's in the water. It has gained one negative electron. Oh, that's why its charge is -1. Okay, Science 10. So continue on with your reading on chemistry, and we'll see you in the next video. Take care.